So here we are, a little road madness. And again, talking about initial conditions and what happens in a dynamic system. So we have accelerations to consider, we have forces to consider. Everything ties together. You can even consider the energy aspect of this. It's usually a pretty educational way of doing it. So here's a car. Pay no attention to the maintenance required sign. We're at 0, forget the RPMs, right? We're at 0 miles per hour. My foot is on the brake. Please do not count this as a driver's ed course. Excuse me. So I have the potential to go up to 160 miles per hour. The likelihood of that is very low, though. I'm wondering if the acceleration of the car would support the distance I could travel. But I can definitely discuss, again, using a parking lot situation, what would happen if I wanted to accelerate up to a certain speed. So let's just set a goal. My goal is 20 miles per hour. I'm in a kind of a short parking lot here. And don't try this at home. So 0 miles per hour, initial speed. My final speed should be 20 miles per hour. I need to accelerate. Now, I didn't say how long I want this to take, but since it's a short distance and I want to actually get up to that speed, I think I'll do this in a short period of time, which means a greater acceleration is needed. So let's do this. Now it's at 20, and I must return back down to 0. We actually just saw exactly the same scenario. We went from 0 to 20, but then we went from 20 down to 0. Now you notice it took me less time to go from 20 down to 0 than 0 to 20. That's only because the force of acceleration was supplied by my engine and I wasn't flooring it. And the force for negative acceleration, which a lot of people call deceleration, was actually going to be greater. So I was able to have a greater negative acceleration because of the mechanics of the system. So if I go in reverse, I'm just changing my frame of reference, but I can still get up to, well, I don't want to hurt my transmission, but I could still get up to 20 miles per hour. Reverse isn't really something that, a gear that's really meant to do that. So there's another nice scenario out here. Let me lead you around. Again, not a driver's ed correspondence course, but I wanted to show you a nice unique patch of ice out here. Now I can take this patch of ice, I want to avoid photographing people. Take this patch of ice, and what we've done is we've decreased the coefficient of friction, both static friction and kinetic friction. Now a car is built usually with an ABS system, automatic braking system, and it attempts to keep you from skidding. Watch, let me show you. Now, if I didn't have an ABS system there, then my brakes actually wouldn't have start, stop like that. And you might have experienced this yourself before. Instead, my tire would have stopped turning, and I would have been under the influence of only kinetic friction, which is much less than static friction. And so when I am rolling the tire, the surfaces very closely resemble static friction. A lot of times it's called rolling friction. There's some distinction made there. But we'll explore this more at a later point. So just again, the idea is you have varying initial conditions. I could start from, say, 10 miles per hour. Let me actually do that. I could say my starting speed is, let me get down to it. Starting speed of, 15 miles per hour. Then I must accelerate. I want to reach 25 miles per hour, which is the speed limit on this road. And I could calculate the acceleration based on the amount of time it took. And you can, of course, find the time it would take, if you want to do a hypothetical situation, just by knowing the accelerations that are available to you. If I applied more gas, you can see I'd have a greater acceleration. but it's not something that you normally would do in your everyday experience. If I want to do an emergency brake, much greater acceleration negatively. Not something I really want to put a vehicle through normally. So that's road madness.